back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And today, we're going to talk about a new look at Darwin's theory of evolution. The book is called Lamarck's Revenge: How Epigenetics is Revolutionizing Our Understanding of Evolution's Past and Present. So the question is, was Darwin wrong? Or maybe Darwin didn't get the complete picture. With us today is Professor Peter Ward. He's a professor at the University of Washington in Seattle, specializing in paleontology and astrobiology. And today we're going to take a new look at Darwin's theory of evolution. You know, when we were in high school, we all learned that there was a debate years ago about why the giraffe has a long neck. Lamarck's followers said that it's the environment. The more the giraffe tugged and tugged on the neck muscles, getting those leaves at the top of the tree, well, these are characteristics that were passed on to the next generation because of environmental pressures. Darwin's theory, however, said, no, it's genes. And simply stretching your neck is not going to affect your genes. Well, this debate is very practical because it affected humans ever since the dawn of humanity. For example, if you're a woman and you're going to marry a man with one arm, and that man lost that arm in an accident, this is a very practical question. Your kids, are they going to have one arm? Or is it in the person's gene, so an accident will not affect the person's gene? And most people would say, well, today we have Darwin's theory, that if you marry a person with one arm that was lost in an accident, there's no way that it's going to affect your kids. But now we're taking another look at that. So, Peter, glad you could be on Science Fantastic.
Michio, thank you, and thank you for having me a second time. I did this with you, I think, 2 years ago with my previous book. So I'm really looking forward to our conversation. And again, thank you.
Right. Well, let's get right into it. First of all, Lamarck's theory, the theory that if you stretch your neck, then perhaps you can pass that on to your kids, that was kind of discredited, at least when I was in high school. But there's a new look at it. So first of all, explain to us, who was Lamarck? What was his theory? And why is he having his revenge?
Well, Lamarck certainly is, to me at least, a tragic figure. He was, before Darwin, he was one of the great naturalists. And if you're ever lucky enough to go to the Great Garden of Plants in Paris, you'll see some of the most spectacular and beautiful buildings that are really edifices of science. Lamarck was the person who designed this entire campus. He put together in the middle of the French Revolution, as heads were being cut off, this idea that science itself needs to be embodied in a series of buildings with a series of professors, each in one discipline. His arch rival was Cuvier, who we call the father of comparative anatomy. Cuvier became so jealous and so angry with Lamarck that when Lamarck died, Cuvier had his body dug up after 5 days, burned, and scattered to the wind. Now, I guess that's Cuvier's revenge, but Lamarck really,
wow.
He gets the last laugh in the end. It's really unfortunate that we keep going back to this old idea of giraffes. It was perhaps the most unfortunate thing that Lamarck ever said, and it's kind of an inside joke. I put them on the cover of the book because it really is a misnomer. And going to your example, would you marry a man who had his arm cut off? Let me give a more precise Lamarckian warning. Would you marry a man or a woman who had gone through a terrible famine, or who had been involved in a gigantic war, or who had gone through and survived an enormous bad plague such as the Black Death? Those people are the people whose genes are changed. It is not this neck stretching. It is going through an enormous environmental catastrophe that causes our genes to not change their code, but get small chemicals to add on to them that causes some genes that would have turned on not to, others that would have never turned on to be turned on in strange ways. And this gets inherited. This is what the Great Revolution of epigenetics tells us.
Okay, well, Darwin himself noted that horse breeders and dog breeders would take certain characteristics of dogs and horses and selectively breed them. And so they refined this whole process instinctively because, of course, there was big bucks involved if you could create new species of horses that would win races. So Darwin seemed to win the day, at least for many a decade. But why is Lamarck coming back after so many decades of believing in Darwin's theory of genetics?
Well, if it were just theory, there would probably be no big deal about it. But you well know that our world is now being transformed in ways that is unprecedented. And I'm talking about the Lamarckian process called CRISPR-Cas9, which is a means to go into a DNA molecule and knock out specific genes and replace them. CRISPR is a Lamarckian effect. Lamarckian means that something happens during the life of the organism that changes what it passes on to the next generation. The great comfort of Darwinian genetics and Darwinian evolution, I should say, is that nothing we do to ourselves during our lives can change our DNA. That this is a Rosetta Stone that is passed on, but it cannot be chiseled in any way to produce new genes. The genes that we have are what we're going to give. The Lamarckian processes indicate this is not true. And this whole idea that we can now change inherited diseases, which is going to be a great godsend, there's also the danger of it. CRISPR-Cas9, I think, is one of the greatest potential dangers facing humanity of anything at all.
Okay, well, some people liken our genome and our DNA to the keys of a piano. The keys don't change. A is A, B is B. The keys don't change, but you can change the sound by hitting the key and activating the key. But the keys don't change at all. But the way in which you play the piano is you turn on certain keys. So some people think that that's sort of like our DNA molecule. The DNA doesn't change, but we change the way we activate the genes. Well, let's take a short commercial break, and we're going to continue a discussion of evolution. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is Professor Peter Ward, author of a new book, Lamarck's Revenge: How Epigenetics is Revolutionizing Our Understanding of Evolution's Past and Present. So we're taking a new look at an old biologist who, back even before Charles Darwin, began to wonder if organisms can change their characteristic generation for generation. So no one is saying that we have to throw out Darwinian evolution out of the window, but people are saying that we have to revise it and refine it, because genes can be activated or genes cannot be activated, and the activation process can be done using evolutionary environmental pressures. And this is where environment can affect our genes. And once again, our special guest today is Professor Peter Ward, Professor of Paleontology and Astrobiology at the University of Washington in Seattle. So Peter, what was it that turned the tide after so many decades of parroting out the standard theory of Darwinian evolution and DNA? What was it that began to turn the tide?
Well, there was a series of experiments that took place way back in the time of the Soviet Union, a number of experiments to try to prove or disprove this Lamarckian contention that effects, things that happen in your life can affect your genome, were done, but they were ludicrous, and they were by a number of these disowned Soviet scientists. One such was Lysenko, the pseudo-geneticist. But at the end of the last century and early in the 2000s, people began to do more interesting experiments, and several that really have affected how we understand this are effects that really came from some of the most horrendous periods of Earth's history and most horrendous periods, especially of human history. The idea that something during your life could affect you came out of the horrendous Dutch starvation period the Dutch winter at the end of World War II, where the Nazis starved the Dutch populace to the point that there were thousands of deaths, but those who survived gave rise to children that themselves had terrible eating disorders. Either they became very thin or very fat. And the surprise was it wasn't just children of women pregnant during the long period. It was children that came from virtually anybody who survived it. So the really crucial experiments were done on rats. And some of the experiments showed that if a rat mother is forced to not give any parental care to the little rats other than feeding them, they themselves became really terrible parents. But an even important rat experiment was that rats that were exposed to a beautiful, what we find a beautiful smell, cherry blossoms, were, when they were given that smell, jolted with electricity. Well, of course, those little rats began to hate cherry smells. The big surprise was the next 3 generations from those electrified rats also, when they smelled cherry blossoms, underwent huge fear reactions. This was something that happened in their life, caused an environmental that itself caused a genetic change that was passed on to next generation. This was a big surprise. But going forward now, we are seeing that many chemicals that we put in agricultural fields are creating changes within us that become probably passed on as they do in the rats. When we expose rats to some of the terrible insecticides that are being used these days and fungicides, 2 to 3 generations after, we find incredibly bad changes in the mental acuity of the rodents still exposed.
Now, in the past, we've had a number of horrible mass extinctions, plagues, disasters, where a good fraction of the population got wiped out, and life bounced back. In fact, life bounced back pretty rapidly. And some people, therefore, think that maybe Darwinian evolution cannot explain how rapidly life bounces back after a catastrophe. So is that where Lamarck's theory comes in?
Precisely, and that's really where I became very interested. As I think you know, my specialty has been past mass extinction, and also considering how the effects of past mass extinctions, which include meteor impact, might affect life not just on Earth, but the potential life we're going to find elsewhere in the cosmos. The interesting study now is that we are merging paleontology and the study of past Earth events with genetics. We're finding, for instance, that Lamarckian change can cause a 3 orders of magnitude, 1,000 times faster production of new organisms, new species, or the change within the morphological size or shape of a particular organ or limb. The rapidity of this is something that the creationists have hit upon for years. They're saying that Darwinian mechanisms alone cannot explain the rapidity we see on occasion in the geological record, the fossil record. Well, it turns out they're right. But what they're wrong about is that it takes some super deity in the sky to do this. We are now finding mechanisms through these epigenetic, or what some people call neo-Lamarckian mechanisms, that can rapidly cause the changes that we see in the fossil record.
Okay, well, let's take a look at the data with regards to past extinctions. The big one took place 65 million years ago. We think that a comet or meteor plowed into the Yucatan of Mexico, wiping out the dinosaurs, and here we are. In fact, if that comet or meteor had not hit the Earth 65 million years ago, we wouldn't be here having this conversation on national radio. So, are you saying, therefore, that life bounced back after this catastrophe 65 million years ago much quicker than the Darwinians would suppose? Is that what you're saying?
Yes, absolutely. And what I've tried to show in the book really is the first time is that we should subdivide geological time into those periods that we call Darwinian, which long, slow evolution taking place through random mutation itself, entirely stochastic, entirely just by chance, compared to periods when there's enormously rapid evolution through the Lamarckian mechanisms, far faster, new species arising, new characters arising, coming about, not through the Darwinian stage methods, but from the very rapidity of the means by which we get these Lamarckian changes, one of the great experiments that really swayed me was the understanding that if you put organisms under stress, and from stress you're talking about major environmental changes that are challenging their lives, mutation rate increases rapidly. If we have even bacterial populations put under stress, the rate of evolution goes up just from mutation rate alone, but there's also these added epigenetic aspects. The combination produces these bursts of evolution. What greater catastrophe could there be except this meteor hit in the Earth 65 million years ago? The rapidity of the mammal bounce back is I think, the hallmark of these epigenetic periods.
So you're saying, therefore, that maybe the rise of humans was a Lamarckian effect, that we humans began to evolve after that explosion 65 million years ago, but that whole process was set into motion by Lamarckian methods. Is that what you're saying?
That's exactly what I'm saying, and probably even more explicitly, my brother is also a paleontologist. He's a physical anthropologist. He is on the paper that defined the very first species of Homo, our group, and that species is first found. Homo, our group, arrives at 2.5 million years ago. This is exactly the period when the ice ages start. The great environmental change of the long, sunshiny sort of life that the world was in all the way through the geological periods until the Pleistocene is a time when the world went upside down. This is when you would expect to have huge amounts of Lamarckian compared to Darwinian change, and this is when our group first appears.
Okay, let's take a few catastrophes and see whether your theory holds up. One big catastrophe was the Black Plague, which hit Europe, wiped out a good fraction of the population there, and hit not once, but several times. And you would expect the bouncing back effect would be Lamarckian. But what does the data show after the Black Plague?
Well, unfortunately, much of what I think is happening, at least in human evolution, after such mechanisms is probably behavioral. And we don't have a fossil record on behavior change.
Okay, Peter, we got to take a short commercial break, but after the break, we're going to continue a discussion of the Black Plague. Lamarck's Revenge is the name of the book. Welcome back to Science Fantastic with Professor Michio Kaku. Our special guest today is Professor Peter Ward. He's professor of paleontology and astrobiology at the University of Washington in Seattle, author of a new book, Lamarck's Revenge, How Epigenetics is Revolutionizing Our Understanding of Evolution's Past and Present. So we're not saying that Darwinian evolution is wrong. We're saying that it has to be revised to take into account the fact that environment does, in fact, play itself out in our genes, somewhat similar to the way melodies are played on a piano. No one is saying that the piano keys are changed. No one is saying that the piano itself is changing. However, which genes are activated, the sequence that they are activated, how they're activated, that gives us music. So once again, with us today is Professor Peter Ward. The book is called Lamarck's Revenge. So when we last left off, we were talking about the Black Plague, which hit medieval Europe, wiping out huge sections of the European population. And are you saying, therefore, that we can actually study the way in which human evolution was in some sense speeded up because of the Black Plague?
Yes, I think at this point, the evolution that probably is taking place and the great unknown and yet the great frontier is behavior. Much of human behavior is coded or affected by genes. We know this is the case. We know the case, for instance, that there is a gene within us. Some people call it the warrior gene. Some people call it the violence gene. But this gene is, in effect, what it does is it can increase or decrease the rate at which stress molecules, called cortisol, are removed from our body. when we're in a very stressful situation where some environmental stimulant causes us to be filled with these stress molecules, and we all know the effects of this, you clutch your stomach, you become worried, you might want to run, you have to deal with this new all-pervasive threat. What if those stress molecules just never disappeared? What if it just stayed within you? And we have people which have genes that do that. And these genes get affected, they get turned on essentially by a Lamarckian mechanism. Violence, some horrible violent episode happening to a human, if they are of a specific genetic type, the gene gets turned on, it stays on. And the cortisol just stays within them. It was the Swedes who began looking, and the Norwegians, and a series of killers in their prison, and began to wonder if there's some genetic aspect. I think what we're dealing with is really cortisol is an amazing molecule. You know, it goes all the way back to the very first fish, the lamprey, the nasty lamprey, which sucks the life out of salmon, was way back 500 million years ago where cortisol first evolved. So we have this blunt instrument, stress molecule within us that hasn't changed in 500 million years, and it does really nasty things to us. And cortisol, when we're just filled with it, it also affects us in an evolutionary way.
Well, as an aside, some biologists have said that it's remarkable that 1 or 2% of the European population is totally immune to HIV. You can inject them with HIV, and they'll never come down with AIDS. And perhaps their immunity is a byproduct of the Black Plague. So the people that survived the Black Plague were slightly better predisposed to be immune to HIV, and we still have that effect today, where 1-2% of the population is totally immune to HIV. Welcome back to Science Fantastic with Professor Michio Kaku. Now, in your book, you mentioned what happened 70,000 years ago. There's a theory that says that 70,000 years ago there was a catastrophe that wiped out most of our ancestors, and only a handful of us, maybe a few hundred, maybe 1,000, survived that catastrophe that then left Africa and populated the rest of the world. And so all of us are basically descendants from this small band of ancient Adams and Eves. Well, Peter, if this theory is correct, that catastrophes in some sense speed up Lamarckian evolution, then what about this catastrophe which almost wiped out the entire human race 70,000 years ago, which may have been set off by the Toba volcano erupting in Indonesia? What are your thoughts?
Yeah, I totally agree that there are, at least anthropologists tell us, and cultural anthropologists, that there are two what they call cognitive revolutions. When it seems that human intelligence vastly increased, it did it by changes in our culture, but it may have done it in just blunt changes of increased creativity, increased what we call intelligence, which is so many different things. One of these happened 70,000 years ago, coincident with this great eruption that you talked about. A second successor was 35,000 years ago, and the 35,000-year-old event led to cave painting, to this absolute revolution in the arts where new tools and new types of weapons were produced. So we have these two great bursts of human intelligence, both of them associated with major environmental change. The world after this great volcanic event was a world in which climate was so radically changed, there would have been starvation, mass starvation, in many parts. And people in Africa that appear to be our direct ancestors were probably forced out of Africa, moving north into Europe and into the Middle East, trying to find places where they could get food to actually grow, where the northern tier of Africa was probably at that time, for very desert-like, it became a very bad place for any sort of food. So we're looking at radical, rapid changes in probably not so much how we look. This isn't evolutionary change affecting how we appear, but it certainly is going to be in terms of our behavior and how we deal and interpret the world. So the second one, the 35,000-year-old event, is taking place when we have these radical climate changes from the ice ages, when we get these enormous climate, the cooling of the world would have been this very stressful event. You have to find food in a world where the climate has so radically changed. And so once again, we see this huge environmental change. Here's what Lamarck said. There's a three-part aspect. Number one, the environment changes radically and badly. Bad things happen. Number two, that requires a change in human or animal behavior. Because of a different environment, behavior has to be changed. Number three, evolution then, as we understand it, can be working on this type of new types of behavior and new consequences that, after all, take place. And so this Lamarckian mechanism, I think, is added to the theory of evolution. It's not a rival. It is an addition to an overall gigantic edifice.
So let me get this straight. What you're saying, to summarize a little bit, is that these catastrophic events, 70,000 and 35,000 years ago, helped to stimulate human intelligence, that it accelerated the development of the brain and culture, the sophistication of society. All of that behavioral changes were stimulated by these catastrophes 70,000 and 35,000 years ago. Is that what you're saying?
Yeah, I mean, this could just be coincidence, but once again, if we take in the fossil record, where I try to break new ground is that, at least in the history of life, epigenetics or Lamarckian mechanisms have never been invoked. And yet we find now...
Okay, let's take a short commercial break, and after the break we're going to continue a discussion with Professor Peter Ward. The book is called Lamarck's Revenge. Welcome back to Science Fantastic with Professor Michio Kaku. Once again with us today is Professor Peter Ward. The book is called Lamarck's Revenge. How Epigenetics is revolutionizing our understanding of evolution, past and present. Now, what you're saying is that even though the human body has not changed much in 70,000 years, what you're saying is that catastrophes, like what happened when the Toba volcano erupted and also the Black Plague hit us several centuries ago, that affected human behavior, meaning specifically we got smarter and more intelligent after 70,000 years ago, and perhaps even more violent after the Black Plague. Is that what you're saying?
Yeah, there sure is an interesting corollary between, again, the major environmental changes and evolution of all groups. It's not always the bad catastrophes, though. Major environmental change also took place with human discoveries. Let's look at the rise of agriculture. A number of workers have noted that some of the most rapid changes in human evolution seem to have taken place with and right after the rise of agriculture, which itself allowed the rise of humans to live in cities. For the first time now, we were using a very different type of food, grains, but we were also placed into near contact with many, many more people than we ever had before. This changed in terms of diseases and parasites. Human genome rapidly changed 10,000 years ago. So this is an environmental change. You would think, oh, no, a catastrophe. I mean, getting bread for the first time, getting crops that revolve is something very good that could happen. And yet, when you think about it, what the rise of agriculture allowed was for the very first time to produce armies. To have a standing army, you have to have enough food to feed it. You cannot have a farmer go off and go to war and come back and tend the crops. With an abundance of food, armies arose. Human history rapidly changed. And with it, increased stress. Where is there more stress than in a battlefield? Unless, of course, it's the stress of seeing all your loved ones die in a disease or watching your loved ones and yourself go through a famine. So it's these great moments in human history, I think, that have radically and rapidly been causing evolutionary change within us through these epigenetic mechanisms, and this is the new frontier.
Okay, let me ask you a speculative question now. What about the future? People have debated endlessly as to whether or not human evolution itself has slowed down or perhaps even changed. In science fiction, you always have the guy of the future with big head, small body, and bald head. But what are your thoughts? Has human evolution changed?
Yeah, I think so, and it's not certainly going to be morphologically. I mean, we are looking right now at a time and where the change is going to take place. We started the segment. There is a mechanism called CRISPR-Cas9 in which we can put new genes or remove old genes, and we're using these to make all kinds of new crops. But we also knew that one of the great Lamarckian mechanisms is when a microbe grabs another microbe and injects, say, half its DNA right into it, causing that creature suddenly to be radically different. Genes jump. The new genes that we're building and putting into organisms are going to jump. And I predict that over the next 500 years, these mechanisms are going to cause radical evolutionary change in plants, animals, and in humans.
And we had one paleontologist who said that perhaps our brain is going to get smaller because we have so many high-tech gadgets to help us do the heavy lifting, cognitively speaking. Do you foresee a time when we're going to have smaller brains in the future, or what are your predictions?
Oh, I think our brain is already so large that I don't see, again, major morphological change taking place, but I certainly see the effects of taking place in terms of behavior. And we go back to violence. What I try to do in the book is use the FBI crime statistics and look at the absolute number of crimes through time. And the violence peaks seem to track. If you start with World War I, the soldiers coming back, they've gone through such horrid violence. The people left behind, the women, the children, the wives, the family, they go through this enormous stress of worry. One generation after World War I, we find a peak in violence. A generation after that, a peak in violence. A generation after that. And my prediction is that the violence we're seeing over the last 5 years has been rising every year. The school shootings, the murders, the really increase in stress in American society is going to peak in 2020. And that we are seeing, I think, we're undergoing some very interesting human evolution as a consequence.
So let's back up a little bit. You're saying that the current epidemic, you may say, of school shootings is in part Lamarckian.
Yep.
1 second to answer that question. Yes or no?
Yes.
Okay. Well, once again, our special guest today has been Peter Ward. The book is called Lamarck's Revenge, How Epigenetics is Revolutionizing Our Understanding of Evolution's Past and Present. Well, unfortunately, that's it for Science Fantastic. Good day.